Okay, here's a quick review about converting variable types. So here we're creating a as an integer and b as a double, and what we can do is convert a to a double and then assign it to b. So this is a way to do conversions of data types, and we use this the convert dot and then something like to double, and the list is here. So here, to boolean, to byte, to char, to date time, to decimal, to double, to int 16, and so on, to string, and so on. Okay, they talk about formatting numbers here. We talked about that before. Here's an example of turning this into currency. So you have this variable here, which equals that. Then you have a string declared. Now we're going to take this here and do the toString method. And the toString method, if you put this inside it, means make it a currency. So this will now have currency. Or you can do it this way. So I'm going to let you look this stuff up. Well, I'll just go through this one quickly, but we don't want to spend a lot of time on this. It says both statements will format like this. So make it dollars with commas. If you're in the United States, if you're using a non-US version, this one will give you the right currency, but this will not. So these are formatting. You can take a look at this. We want to talk about user-defined data types. So this is a big new subject. It's actually en route to understanding objects in a more formal way, more clear, more detailed way. But anyway, this is good. User-defined data types. So the data types we know about are integers and doubles and strings and dates and so on. But we're going to be able to create so-called user-defined data types. Now before we go on here, they're going to talk about something called a checkbook, which isn't so widely used outside of the United States, I think. I know at least in Japan they don't use checks. So let's just see what a check looks like. So this is called a checkbook, and it holds checks. This is called a checkbook, and it holds checks. This is called a checkbook, and it holds a check. This is a check. This is a check. And in the way these are used in the United States is you write down who's going to get this money, and you write down the amount, and then you have to write the amount down here with using numbers, and then here you write it out in English, like you'd say $125. You have to write it by hand, and then you sign the check here, and then you give this to somebody, and they take it to their bank. They give it to their bank, and then maybe it takes a day or two before this money actually appears in their account, because this check gets sent or somehow communicated with your bank to verify that you actually sent it or whatever. Somehow they check it, and then the money gets actually given to the person that you wrote the check to. Okay, so that's called a check. Now, obviously, if you want to represent a check in terms of a program, you might treat it as like an object, or in this case, not having talked about objects formally, we're sort of on the way. You might have a data type called a check, and the check will have various properties, but it won't have methods. Okay, so that's basically the difference between an object and what we're talking about now. So it won't have methods, but it will have properties or values. So you might have a date property, and you might have an amount property, and you might have your name property or whatever. Okay, so let's see. Okay, so we're talking about user-defined data types. In the previous sections we used variables to store individual values, or scalar values, as they're called. As a matter of fact, most programs store sets of data of different types. For example, a program for balancing your checkbook means like making sure you don't spend more money than you actually have in your account, must store several pieces of information for each check. The check's number, so checks have a number also, so you don't kind of get mixed up. So, when you write your first check, it might be called 001, and then the second check you write 002 or whatever. And the amount of the check, how much money, the date, and so on. So so you want to store several pieces of information together. All these pieces of information are necessary to process the checks, and ideally they should be stored together. What we need is a variable, so not just like an integer variable, or not just like a date variable, but as kind of a special type of variable that can hold multiple related values of the same or different type. In other words, maybe the date. So we want this this variable to contain the check number, to have the check number in it, and the check date and the check amount. So this will be like I guess maybe a double, and this will be a date, and this might be an integer. So it's going to have different types. So you create a let's see, what we need is a variable that can hold multiple related values of the same or different type. You can create custom data types that are made up of multiple values using what's called structures. So it's like an object, but it's simpler. A structure allows you to combine multiple values of the basic data types and handle them as a whole. For example, each check in a checkbook balancing application is stored in a separate structure or record, as shown in figure 2.3. So we have our first check, which was check number 275 on this date, this amount, and it was paid to this company or to this person. And then check number 276 was this, and that, and so on. So this would be called this first row would be often called a record, but it's also called a structure, one structure, or one structure or one record. Now, how do you create this kind of checkbook structure or check structure in Visual Basic? To define a structure in Visual Basic, you use the structure statement, which has the following syntax. So you first write the word structure, and then you write the name, so you might call this check, and then you say, okay, well, I'm going to need an integer type, so you'll call it check number, and it'll be of type integer. And then you'll say I'm going to need a date type, so you'll call this one like check date, and it'll be of type date. And you do this as many columns, so to speak, as you need. And then you write the end structure, and then you've created this check structure. So what do I mean? So and also they say that instead of dim here, you can use private or public. They say dim is equivalent to public. After this declaration, you have in essence created a new data type that you can use in your application. Structure name can be used anywhere. So let's say, okay, here's an example. Check record. They're going to create a structure called check record, and this is going to be an integer, and this is going to be a date, and this is going to be a single, and this is going to be a string. Okay? This declaration must appear outside of any procedure, so you don't do it inside a procedure. You can't declare a structure in a subroutine or a function. Once declared, the check record structure becomes a new data type for your application. So what do they mean by that? So you can declare variables of type check record now. So you can say dim check1 as check record, dim check2 as check record, and so on. So now check1 is a check record type thing. And then what you do is you say, okay, check1 was of type check record. You can say check1 dot check number. Remember, check number was the first basically property of this thing. So you're going to say, okay, for my first check, for check1, the check number is equal to this. Okay? And then you could, let's see, don't they give us a few more? So check2 is going to have this for the check number, and then you assign the date. It's going to be that. And you assign the amount is going to be this, and the check paid to is going to be this. Okay, so now you've assigned a what do they call it? A check record. Okay, so that's how you create a structure, and then you can now you have a structure called check, and it's kind of very convenient. You have you can create checks and have all these properties filled in, or you can fill in all these properties. And not only can you fill them in, but you can also access them. So if you have check1, you can say check1.checkNumber, and that will, and then you can figure out what the check number is for check1 by accessing that property. So they say to assign a value to any one of these variables, like this one, this one, this one, and this one, you must separately assign a value to each one of its components. So like this. They are called fields. So these are called properties, but here they're called fields, which can be accessed by combining the name of the variable and the name of a field separately, separated by a period, right? Just like we've been doing. Actually, as soon as you type the period following the variable's name, a list of all the members, or all the fields, to the check record structure will appear as shown in the figure. So IntelliSense will show you all the different properties that you defined plus a few extras. Notice that the structure supports a few members on its own. So you didn't write any code for equals, get type, or toString, but those will also appear in the IntelliSense list. They're standard members of any structure object, and you can use them in your code also. Both the getType and toString methods will return a string like project name.form plus check record. You can provide your own implementation of the toString method. So suppose when you do check1 dot toString, you don't want it to print out exactly what Visual Basic.net will print out. You can actually change what it will print out by rewriting the toString method. The way you rewrite the toString method is you do this. You say you just write this, overrides the toString method like that as string, and then you can rewrite it, and you just say what you want it to return instead of whatever the default that it would return is. So here I want it to return quote, and then where's the end of the quote here? No, sorry, here's the end of the quote, and then here's another quote, whoops, and here's the end of that quote. Okay, so what do I want it to return? Check number, and then concatenate check number. I guess you don't need to write dot check number, you just write check number, and that will be the number for, and then concatenate the check amount and format it as a currency. Okay, so you could rewrite the standard toString method like this. The only thing is I'm not quite sure where you're supposed to put this, because it doesn't mention which toString method, right? This is the toString method for our structure, but it doesn't say that here. So how does it know that that's for the toString method for this checkbook what is it called? Check record structure. So I'm not quite sure of that actually. We have to check that a little further. They say, as you can see, structures are a lot like objects that expose their fields as properties and then expose a few members of their own. So we might say, remember we talked about inheritance. So even though we create a structure called checkbook, or what was it called again? Check record. Even though we create a structure called check record, it still so-called inherits certain other properties that even though we didn't write those properties, it still inherits them from a general structure type object or structure type class. So it inherits what? The toString method, for example. We didn't write that necessarily. We did write it here, but even if we didn't write it, it would still inherit a toString method, and it would still inherit, what were the other things? Equals getType also, even though we don't write them. So we could call that an example of inheritance. Inheriting from a kind of general structure class. And then this is an example of a particular structure class.